Hey guys, how's it been going? This is Jaser. In previous video, I've talked about how hydration works with suspense. I've left one question untouched. That is the something called pending suspense, which is the dollar sign with a question mark. So today, let's continue our investigation into that. That is actually called progressive hydration. To understand how progressive hydration works, we first want to know what problem progressive hydration tries to solve, right? So let's take a look at this basic example. This is a component that fetch some data from a database and throws here, and then we can use a suspense that wraps this component, right, and render a fallback. This looks pretty normal, and then with what we learned from previous episode, that we can actually serialize the suspense with a comment node like this one. When it throws, we could render the dollar sign. Now here's a question: when we send this piece of code, like this HTML to the client, how do we feed the client code with this data, list data, right? If you waited, like say, if you wait this wait this list without the suspending, then the initial load for the app will be deleted, right? Or will be super late. We don't want that. That's why we want suspense. We want to show the fallback first. But if we send the code down and have the component request this list again through some data API endpoint, it will still be we create some kind of waterfall, right? We get this fallback, download the JavaScript, exit the JavaScript, send a request, and get a response back, and then update. It works, no problem. But have you noticed that the initial request for a list is wasted? Initial request of this list on the server side is wasted, right? It's kind of like we request this data, but merely for the triggering of the suspense. So this kind of waste, how can we improve? Actually, the natural idea is that, okay, since the data is already requested, why don't we send down the HTML when it's ready? So that's the core idea of progressive hydration, I think. So that's the solution. We continue the initial query that suspends on server and then sends down the new contents of the suspense and then sends the final HTML separately when ready. So for the streaming, I had a very basic demo. You can take a look at the
Hey guys, how's everything going? This is Jaser. Recently I'm
YouTube channel. It's actually pretty simple. Here,
taking a look
let's
at
just pause it a little bit. We can see that rather than use REST sending, this is based on the express. We use write, and then from the client side code we could use this. It's called body reader, a stream reader. We can get the response from a reader and read the data chunk by chunk rather than away them, all of them. So basically, the client, the fetch will wait for all the chunks and then put them together and then do the decoding stuff. But we can get a lower level API, which is this reader, and to read the data chunk by chunk. That is how we can get it streamed. So back to the progressive hydration, we can see the test case called react.physServer. The test case, it's the from the React repo, and lock down the output result. We can see what is being transmitted. So for the initial response, we can see this is the question mark, right, for the suspense, which means that it's progressive hydration. And then there's something called template, which sounds interesting. There's ID there, B, maybe boundary 0, and this is the fallback, and this is the ending of the suspense. Because we have put two suspense there, there's a two template. The second one is B1. This obviously is some kind of unique ID. and then the promise resolves, and we have another piece of HTML being transmitted. This is the initial data, and this is the extra one. We have a div, and then we have marked as hidden, have an ID S. I don't know what S for, but anyway, the 0 I think it's kind of another matching ID to this boundary, and then this is the content, right? Okay, and then there's a script, and this script, I don't know what it's doing, blah blah blah, but there's an insert, right? This said insert something, and then this is a hidden ID S2, okay, and RC blah blah blah. Cool. So I think from this piece of code, we can guess that basically first we render the encoded suspense, and then when everything is done, we send back the extra HTML with sort of a script which we can hook into the React runtime, and then we continue our work there. Cool. And how does it work? There are 3 questions we need to answer. The first one is how we defer the rendering of suspense contents, right? The second one is how we handle the question mark. And then 3, how we can trigger the re-render. So the first one, how we can defer the rendering of suspense contents. We know that JSX is compiled, like this piece of code is compiled to something mostly, I think, yeah, to create element. This is because JSX is it could be used in many libraries, not only React, Vue could use it, Solid use it. So their compiled result might be different. So most of the time, I think for React default is something called create element. And when it is evaluated, it will return something like this, JSON. Oh, not JSON, yeah, it's JSON-like. Some of the data cannot be serialized and deserialized, but we can see some tree-like object like this. We have this type of React element and props. Props could have the ref, children stuff. Oh no, ref is not part of the prop. Sorry, children. And then we have the type, and then the children. We could have the other element props. So this is kind of tree-like. So we want this kind of like get this thing rendered in batches, right? So how can we do that? Obviously, for the suspense, we could try something like try catch, as it should be. When the promise is thrown, we can catch this promise and attach a then if listener to this promise, and then send it the response back. So this is a demo of how it might work. It's not the progressive hydration, but it's a demo to illustrate that we can defer the chunks. Here, thanks for app. We use these set chunks. We set pipe and render to pipe. This is JS. This is JSX. We have 2 suspenses and another p tag, and pipe it. So in the render, we just use recursion. Recursion is bad. This is just demo code. Don't trust it. It shouldn't be used. But this is for demo purpose. So if it is normal data, we just render it. If it's string, it means that it's HTML tag. It has children. We need to render the children as well. So we recursively call render on this children. This array, we map it with this function. We just render it. If it is suspense, we expect this whole process to be synced. So we can have this try catch. We render this thing, the children wrapped with this div hidden. We've covered this like the following chunks should have things wrapped up. Wrap div, a script. This is some script we need to add. And the ID. We need some unique ID to be paired. So we put this data into this context. The context has this ID, and also have this pipe we can use. Okay, so if the promise is throw, we copy this current context, and then we set up a then callback. And then after it is done, we will render this JSX again, because this is suspense, render it again, and then we will pipe the response. And then what we return, this is the initial render, so we don't stop here. When that promise is thrown, we will render immediately for the fallback. So we get to render fallback, and then set up the thing to pipe the contents later. So this is basically code. We can see we render it. we get the fallback first, right? B0, B1. This is all fallback, and this is the question mark. And then we get the second chunk, which is diff hidden, which matches for the first boundary, and this one matches for the second boundary. This should be good. So even if I think even if there's a nested boundary, it could still work. I think because if like say here continuously there is another suspense, we would have increasing ID as well, and then we have this extra callback being set up. So anyway, this is a demo for deferring the rendering of suspense. So yeah, it should be fairly easy, but we will skip for the real implementation in our episode. It's not our critical topic for today. Second thing is how this question mark is handled. I think we've briefly touched it in the previous episode, but in update suspense component and update dehydrated suspense component, there is a function. There is a branch called is suspense instance pending, which use this question mark to determine if the suspense instance, which means this common node, is fallback or pending. You can see that interestingly for this branch, it still returns null, means that it will not go down to this parent. And also, there's no mount suspense primary. No, there's no scheduling of second render. In our previous episode, we've seen that here actually. Mount, where's the mount? Yeah, if here we mount the hydration component and we schedule a re-render because the hydration of suspense is too past thin. We set the lanes, but on this progressive hydration, there's no such thing. We just you see, we only set up the retry to the instance, and we don't set the lanes. You can see we don't set the lanes. We just set the flags to mean that it's already thrown. We don't touch the children. It returns now, as I said, no going deeper, and different from hydration. There's no mount stuff. Tries another render. It means that the contents will totally be kept there without being touched. The re-render stuff, the re-render will be set as a secret method on this instance. This is a common node, and yeah, that's it. And it basically means that during when we first handled this pending suspense, we do nothing but defer the timing of re-render, which possibly will do the future hydration lift as a callback here. So this method, when will be called? Well, the script we get from the test code, you see that there's there's a piece of chunk of script code, right? Actually, we can get the source code for that. This actually is called complete boundary. The code is a bit long, but basically what it does is that you can see here, we get the content node, and then we get the suspense, which means the container node. And then what we do, we would here, we will remove the existing DOM and then insert the new DOM. So it basically is a re-render, and then we will trigger the React retry. Yeah, let's do some a bit of summary. Yeah, the suspense boundary is the B something, and then if actually actually the template stuff is target and gets the previous sibling. Interesting. And then we get the content is the S, and then child will be deleted and this content will be inserted, and then the React retry will be called. Retry, as we said, is set up during the first round of hydration. And while we're using template, yeah, there's a reason here. I don't know actually so much deep knowledge of HTML. It says we want some node, could be filled later, but before it is never visible. We can use template because it can be used in every element. But script tab could also work in other tab except column group. Why why script cannot work under call group. I don't know. But anyway, it's just a chosen for it do no harm to other elements. Okay, so inside of this retry, let's take a look at its content. You can see that it basically does nothing. It's just the sets up the retry lane, mark root updated, and ensure root is scheduled. As we mentioned in previous episode, we just set the lanes in the normal hydration, because in the committing phase there's automatically triggering of this method. So in our new one, in this progressive hydration, there's no committing phase waiting for us, so we have to manually set up this check. So set up the lane, set the check. It's basically similar to what we have seen in previous episode, right? Set up the lane to mean that there's more work to be done. So yeah, that's it. If that's how progressive hydration works, remember for the normal hydration, as we said, is basically 2 passes, right? The first 2 pass process, in order to put in the low party, the first pass doesn't go down to the children, and in the second pass, we will go down to the children and let it throw promise, let it suspend. But for progressive hydration, once the first pass is done, we don't schedule work right away. We defer the re-render, means defer the second pass to the timing of the following chunks. Okay, so progressive, yeah, that's it. That's how it works for progressive hydration. Oh yeah, let's summarize. On server, if suspense is suspended, React sends down the fallback first, mark as question mark here, and later it will stream down suspense contents, different chunks, and the different chunks has a script which will trigger the retry callback, and the callback is set in the initial hydration pass, and after that it's the same as normal hydration. Yeah, and there might be multiple suspenses. React will keep track of them by this unique ID, so that the following contents could be matched without any errors. That's progressive hydration, which is pretty simple, right? It's much simpler than I first thought. Interesting. Cool. I think that's all for hydration. The next one, I will go to server component, which is pretty interesting. At first thought, it will be related to reactive, related to hydration, but actually it is not that related. It's totally different concept. So that's all for hydration. We use 3 episodes from basic hydration, hydration with suspense, and progressive hydration, and we will spend maybe 2 to 3 episodes on Rack server component. Yeah, cool. Hope it helps. See you next time. Bye.